Today we are going to start with the Laplace transforms. Right. So this is one of the most easiest topic. Here, first of all, why do we need to learn Laplace transforms? Is there any specific reason why we are learning Laplace transforms in mathematics? What is the great advantage of Laplace transforms and what is the purpose of Laplace transforms? Somebody tell me what is the purpose of Laplace transforms? Not from the examination point of view, in engineering. What is the problem that Laplace transform is addressing? Exactly, right? So solving the differential equations. Yes, Laplace transforms has got very great advantage in solving the differential equations. And the main purpose of the Laplace transforms is to solve the differential equations and the integral equations. Now, in engineering, almost every problem statement is built with the common words called moving, changing, oscillating, time varying or varying. So this is completely a changing phenomena. All these words are actually a changing phenomena it will represent. Now any problem statement which was framed with these words will lead to a differential equation. There is no other equation at all. So it will always lead to a differential equation. Now the solution of the differential equation is nothing but the solution what we are looking for in the physical problem. Now if the solution is the differential equation, so the solution we need to be finding out for the differential equation, and in the normal ordinary differential equations method, it's quite tough to find the solutions for certain kind of cases, especially the nonlinear differential equations. Now to solve such kind of differential equations or to make the simplicity for the normal ordinary differential equations, there is a great tool called Laplace transforms, which will give you the only method, that is changing the differential equation into a linear equation, into a polynomial equation. And this is the only purpose of the Laplace transform. It will change the differential equation into a polynomial equation. Now you know certain methods to solve the polynomial equations, but the differential equations may be tough to solve, but the polynomial equation may be easy to solve. That is the greatest advantage of Laplace transforms. Got it? Understood or not? So why we are learning the Laplace transforms is just to change the differential equation into a polynomial equation and solve the polynomial equation and then convert back to the original time domain equation. So here Laplace transform is a tool or an operator which will convert from one particular variable to another variable. So that is that usually the time domain equation to frequency domain. Here f of t is converted into f of s format. So this is the frequency, complex frequency. This is a complex frequency, yes, usually a complex number. T is the time. So the time domain function is converted into a frequency domain function. Here the way we convert is, that is the Laplace transform of f of t is converted into the Laplace transform form is f of s or f bar of s. So whatever the convenience, you can use that. So f bar of s is nothing but the variable, here it is t. Here it's a different function, it's not f. So the converted function of f into the frequency domain s. Got it? So this is the Laplace transform. In mathematics, if at all you find an operator, definitely you will be having the inverse operator for it. Here Laplace is a operator which will convert time domain to the frequency domain. Then there has to be an inverse operator which will convert this Laplace transformed function to the time domain function. So this is f of t. So the way we have done for the differentiation is an operator, d by dx is an operator which will convert the function into the differential domain. And exactly in the opposite manner, there will be an integral operator which will convert a differentiated function into the normal function. So differentiated is, so d by dx is an operator, then exactly in the counter way, there will be an integral operator. So these two work oppositely. Exactly in the similar manner, Laplace transform is an operator. The inverse of that has to be there so that you can bring into the original format. Suppose if you take logarithm, log is an operator, anti-log is an inverse operator. So this way in mathematics, as and when there is a requirement to define an operator, there has to be an inverse operator as well. Such kind of operators are, certain examples are this: Laplace transform, derivatives, log, anti-log, all those things are the such kind of applications what we are using in mathematics. So, but the base root is all these things actually we are bringing into picture only to simplify the problem statement. That's it. We are simplifying the problem statement. We are giving the solutions in a better way. That's it. Finally, what we are targeting is to solve an engineering problem. Nothing more than that. Right? So you can note down this. So the operator has to be defined, but the inverse operator has to be built from the definition. Right? Once you note down this, I am going to define the Laplace transform. That is the purpose of Laplace transforms. Now actually, the way we define the Laplace transform is Laplace transform of any function f of t is defined as integral 0 to infinite e power minus st f of t dt. This is the Laplace transform definition. Now this will convert into a function of f of s alone because this is a definite integral. Limits 0 to infinity. This is a definite integral, and this is the function which has to be converted into Laplace domain. This S plays critical role. This is the parameter. Can be a complex constant also. So this is the definition of Laplace transform. Now with this definition, you will be able to find, as long as if you are able to find the integral of it. So any function you can think of, as long as if you are able to find out this integral value e power minus st into f of t, then you should be able to solve that integral. Now, I'll take one function. Let us say the Laplace transform of the constant 1. So the Laplace transform of constant 1 is integral 0 to infinity e power minus st, and in place of f of t, the constant 1 and then dt. So this integral value is coming out to be e power minus st divided by minus s, and the upper limit is infinite, lower limit is 0, then it will be 0 minus e power 0 by minus s. This is equal to 1 by s. Got it? This is how actually we will be finding the Laplace transform. For any function, as long as if you are able to find out the integral value, you will be able to find out the Laplace transform. So if you notice, this is the function in time domain. So anyway, this is a constant. It doesn't matter whether it is time domain or not. But the result that is coming out to be a function of s. So that's why this is usually represented as f of s or capital F of s or small f bar of s. So all the terms represents exactly the same. But you have to notice that this f is different from the original function f. Got it? Now what is the Laplace transform of t? Usually the Laplace transform, right? Most of the times we are using this Laplace transform while converting from time domain to the frequency domain. So that's why the standard convention is usually we use the variable t rather than x. Right? But it serves the same purpose. Now what is the Laplace transform of t? What is the Laplace transform of t? By s square. How? So this is, you need to find out the integral value. Integral 0 to infinity t into e power minus st dt. And this integral value you have to find it out and substitute the limits. You are going to end with 1 by s square. Now what is the Laplace transform of t square? What is the Laplace transform of t square? 2 by c cube. What is the Laplace transform of t cube? What is the Laplace transform of t cube? In general, the Laplace transform of t power n is n factorial divided by s power n plus 1. This is the Laplace transform of, for the base functions, you can remember. But if you are able to solve this, you will be able to find the Laplace transform without having any doubt. This is normal UV formula you need to be applying, that is by parts. Integration by parts you have to do it, and then you can substitute the limits, you are going to end it. Hope I don't need to do this. Okay. So you can note down this. I am going to list down some of the base formulas. Laplace transform of t power n is equal to n factorial divided by s power n plus 1. Laplace transform of e power at 1 by s minus a. Laplace transform of sin at this is a by s square plus a square. Laplace transform of cos at is s by s square plus a square. Laplace transform of sin hat a by s square minus a square. Laplace transform of cos hat is s by s square minus a square. So these are the basic formulas of Laplace transform. Now actually, can you prove what is the Laplace transform of e power at? Prove this. What is the Laplace transform of e power at? This is one of the important property which we call as the first shifting property. First you find out what is the Laplace transform of e power at. I hope you should be able to do that. This is simple integration. Okay. So let me find it. So Laplace transform of e power at is nothing but integral 0 to infinity e power minus st into the function value is e power at dt. So this is integral 0 to infinity e power minus s into s minus a into t into dt. So e power minus st, e power at, if I add it together, e power minus s plus a. So if you take minus out, e power minus s minus a into t. Now let s minus a is equal to p. And this is s minus a. So the limits values when s is 0. Yeah. So you can just, okay, you don't need to change the limits. So integral 0 to infinity e power minus pt dt. So here limits actually you are not changing because s minus a is a parameter, not a variable. So s minus a you can replace with another parameter called p. Now actually I have got the parameter value p. Now here this is nothing but Laplace transform of e power, so Laplace transform of 1 with the parameter p. So this is nothing but f bar of p. F bar of p. Now f bar of s actually we found when the constant is 1, right? So the Laplace transform of 1 is found to be 1 by s. Here 1 by s, instead of that it is 1 by p because it is a function of p now. So but p is equal to s minus a. This is nothing but 1 by s minus a. Got it? Understood or not? In general, Laplace transform of e power at into f of t. So this is nothing but integral 0 to infinity e power minus st into e power at into f of t dt. So this is integral 0 to infinity e power minus s minus a into t into f of t dt. Now this is as if like s became s minus a, but it is the Laplace transform of f of t only. So this is, if you replace with p, integral 0 to infinity e power minus pt e power minus pt f of t dt. So this is nothing but Laplace transform of f of t with parameter p. Now but p is nothing but s minus a. So this is as if like changing the variable to s minus a. Just a minute, I am getting a call. So you understood, right? So this is what we call as the first shifting property. So this first shifting property, what it says is, suppose if you know the Laplace transform of any function f of t, then the Laplace transform of the function f of t getting multiplied with e power at is nothing but replacement of the Laplace transform s with s minus a. That's it. That's what we call as the first shifting property. Got it? You can note down this. This is the proof for the first shifting property. So this topic won't take much number of hours. So maximum 5 hours. So the sections that are involved are, one is the fundamental properties of Laplace transforms and finding out the Laplace transform. Another is finding the inverse Laplace transform and convolution theorem, and finding the solutions with the help of Laplace transform. These are the sections that are involved in it. Okay. Okay. So this is e power at. So this is Laplace transform of sin at. This is nothing but integral Laplace transform of sin at equal integral 0 to infinity e power minus st. Instead of f of t, this is sin at. So this is, what is the Laplace transform this? So this is, you need to find out this value, integral e power at sin bt dt. Formula you might be aware of it already. So this value is nothing but e power at by a square plus b square e sin bt minus a cos bt. A sin bt minus b cos bt. Yeah, this is the formula. So you need to apply that formula and then find out. And so the limits you need to substitute in this. So this is e power minus st divided by s square plus a square into minus s into sin at, sin at, yeah, minus a into cos at. So you need to apply the limits 0 to infinity. This will simplify to a by s square plus a square. That's it. This is the Laplace transform. Similarly, the Laplace transform of cos at, exactly in the similar manner, you need to find out that, and then this integral value. If you don't remember this formula, apply by parts, integration by parts. So integration by parts is integral u dv is equal to uv minus integral v du. So this is the formula that you have to use in the Laplace transforms. So this is always required. So this is the only formula that we are going to use in entire Laplace transforms topic. But to find out the Laplace transform. But most of the cases, what you do is you will depend on the basic function transforms. You will try to convert every function into the basic functions and then try to find out the Laplace transform of it. Got it? So this one, if you find the Laplace transform, it will be s by s square plus e square. Similarly, the Laplace transform of cos hat. Cos hat is nothing but e power at plus e power minus at by 2. So this is cos hat. So for this actually you need to be finding out the Laplace transform. This is nothing but 1 by 2 into Laplace transform of e power at plus e power minus at. So this Laplace transform, you can use the first shifting property. E power at is nothing but Laplace transform of 1 with a shifting of a. So that is 1 by s minus a plus 1 by s plus a. This is the Laplace transform. So if you simplify this, this is a by s by s square minus a square. Similarly, Laplace transform of sin hat. This Laplace transform of e power at minus e power minus at divided by 2. So this will be exactly the same thing, but instead of s, it will be a by s square plus a square. That's it. Minus a square. Sorry. Got it? So you know how to find out the Laplace transform of any simple function. So note down this, make it fast. Then note it down. So linearity of Laplace transforms. Linearity is nothing but it obeys the linearity principle. That is Laplace transform of a into f of t plus b into g of t is equal to a times Laplace transform of f of t plus b times Laplace transform of g of t. So this is what is called the linearity principle. Is obeyed by the Laplace transform. Is obeyed by the Laplace transform. First shifting property is anyway known, that is Laplace transform of f of t is equal to f of s, then Laplace transform of e power at into f of t is nothing but f of s minus a, the first shifting property. Now, based on this understanding, second shifting property I am going to discuss tomorrow. Based on this understanding, try to find out some of the Laplace transforms. Find the Laplace transform of sin 2t, sin 3t. Somebody tell me what is the Laplace transform of this? Sin 2t into sin 3t. Okay, that's correct. So 12s by s square plus 1 into s square plus 25. Anybody got the same answer? Anybody got the answer? Nobody could able to solve. Sin A sin B equal to 1 by 2 times of cos A minus B minus cos A plus B. This is the base principle that we need to be using, because you know the Laplace transform of sin AT, but you don't know the Laplace transform of the product of two different sine functions. Now that's the reason we have to convert into this format. Now this is sin 2t, sin 3t can be converted into 1 by 2 times of cos t minus cos phi t. Now, you know the Laplace transform of cos t is nothing but s by s square plus 1 minus s by s square plus 25. Now, the simplified form of this is 12s divided by s square plus 1 into s square plus 25. This is how you need to find out. Got it? Understood or not? Find the Laplace transform of cos square 2t. What is the Laplace transform of cos square 2t? Square paid by 8 divided by s square plus 16. I think that's correct. What is the Laplace transform of sin cube 2t? What is the Laplace transform of sin cube 2t? So you have to be aware of this formula. Sin 3 theta is equal to 3 sin theta minus 4 sin cube theta. So he asked us to find out the Laplace transform of sin cube 2t. Use this formula and then try to find it out. Forty-eight by s square plus 4 into s square plus 36. That's correct. Now find out what is the Laplace transform of t sin at. T sin at. What is the Laplace transform of it? Fast. Not many people are answering the questions. First, I have to know whether you have understood or not. See this. Let us consider Laplace transform of t into e power iat. This is nothing but Laplace transform of t into cos at plus I sin at. So this is from the complex principle. This is nothing but Laplace transform of t sin at plus I times of Laplace transform of t cos at. This is t sin at. Got it? Now this is Laplace transform of t sin at. First you need to identify what is the Laplace transform of t. T is nothing but 1 by s square. So instead of s, this is s plus ia whole square. Got it or not? S minus ia, sorry. S minus ia whole square. This is the Laplace transform of it. Is this understood? Understood or not? This is with the help of first shifting principle. I found the Laplace transform of t is nothing but 1 by s square. So that is getting multiplied with e power at. So instead of a, it is ia. So that is nothing but 1 by s minus ia whole square. Now what I will do is I will multiply with s plus ia whole square at the top and the bottom. And this value is coming out to be, at the top it will be s square minus a square plus 2as into I divided by s plus a into s minus a. So that is s square plus a square whole square. So this is nothing but s square minus a square divided by s square plus a square whole square plus I times of 2as divided by s square plus a square whole square. So this is nothing but you can equate the corresponding terms. This is the Laplace transform of t cos at. This is the Laplace transform of t sin at. Got it? Understood? So by equating the corresponding terms at one stretch, you will be able to find out the Laplace transform of t sin at and t cos at. Any questions on this? Understood or not? Find the Laplace transform of the function is defined as f of t is equal to t by tau when 0 less than t less than and this is equal to 1 when t greater than tau. Find the Laplace transform of it. I'll give you 5 minutes time. Try to make it and solve it on your own. Yeah. So 1 minus e power minus s tau divided by s square tau. Yeah, that's correct. Now here, the way we need to proceed here it is, this is the Laplace transform, nothing but f of t is defined as integral 0 to infinity e power minus st f of t dt. So this is the Laplace transform. Now here, these limits actually needs to be divided into two different roots. So that is integral 0 to tau. This function is varying as t by tau, e power minus st into t by tau into dt plus tau to infinity. This is varying as e power minus st into 1 dt. So this is how actually you need to find the integral and apply the limits to get this answer. Got it? Now, note down one more, that is Laplace transform of f of t, where f of t equal to mod t minus 1 plus mod t plus 1. Can you find the Laplace transform of mod t minus 1 plus mod t plus 1? It's all just finding the integral. If you are not able to find the Laplace transform, means you are not able to solve the integral, that's it. Got it? Anybody? First you need to identify this curve, how it is going to be. If you notice, this curve is nothing but, this is x-axis and this is y-axis. For different values of t, you substitute and find out the value, then this is coming out to be from minus 1 to plus 1, this will be a constant value. So, and the value is coming out to be, so if I make it t equal to 0, this is plus 1 and this is plus 1, both will be 2. From here, it will be linear like this. This is a curve. This is a bathtub curve. Mod t minus 1 plus mod t plus 1. At t is equal to 1, there is one sharp edge. At t is equal to minus 1, there is one sharp edge. And rest of the places, it will be a linear curve. And it will be a linear curve here. It is a constant value here. Right? So now, but for finding out the Laplace transform of f of t is nothing but integral 0 to, we need to start. That means you need to rule out this curve. You have to start from here only. So till this point, that is 0 to 1, value is 2. And from 1 to infinite. So this value is as if like, you can substitute the value here. So 0 to 1, this value is 2, just 2, into e power minus st into dt, plus integral 1 to infinity. So if you notice, at 1 to infinite, this is all positive value. So t is more than 1. That means t is equal to 2, let us say. This is a positive value. This is also a positive value. You can replace as if like there is no modulus. Because both are positive. You don't need to change the sign. So this t, this one, so this one will cancel. This is going to be 2t. So this is nothing but y is equal to 2t is the curve. So here y is equal to 2 is the curve. So this is 1 to infinite e power minus st into 2t dt. So this is the integral value we should put, you need to find it out. Got it? So 2 by s into 1 plus e power minus s divided by s. I think that is correct. Yeah. 2 by s into 1 plus e power minus s by s. That's correct. Now, I hope everybody got the answer. So this integral you have to find it out. That is a simple integral only. This is the final last question. You should be able to solve this. If you solve this, you know how to find a Laplace transform. Now, what is the Laplace transform of step of t? What is the Laplace transform of it? Where step is the greatest integer. You have to solve this. First of all, you need to identify the curve, how it is going to be. So, yeah, it will go to infinite, exactly. So y is equal to step of t. Step function is nothing but, suppose if 0.1 is there, for this number, the step value is the greatest integer, which is nothing but 0. Here, let us say 1.5, the step of it is 1. So this is the part which we are going to take it up. But don't get confused, if it is a negative value, this is minus 1.5, then this will be minus 2. So if you take it on the real line, it will be on the left side of the real line. So that is, suppose this is 0 and this is 1, this is 2, this is minus 1 and this is minus 2. Now if you consider a point here, that is the greatest possible integer is below that. So that is 0. For here it is 1. Here it is 1. Suppose if you take it here, the greatest integer is this one. If you take it here, let us say minus 1.5, the greatest integer is on the left side only. So that's why step of minus 1.5 is minus 2. Step of 1.5 is plus 1. That is the difference. You notice always step x plus step of minus x will be how much? Somebody tell me what is the value of step x plus step of minus x? Somebody tell me what is the step x plus step of minus x value? It's not 2x. Anybody else can guess what is step x plus step of minus x? Nobody could be able to guess. Value is minus 1. Here if you notice, you take this point, let us say or 1.5 I will take it. So for 1.5, step of 1.5 is plus 1, step of minus 1.5 is minus 2. Plus 1 minus 2 is minus 1. If you take any other value, 3.5 let us say or 3.2, step of 3.2 is plus 3, step of minus 3.2 is minus 4. Minus 4 plus 3 is minus 1. That's why if you take always step x plus step of minus x is always equal to minus 1. Got it? So this is how you will be finding it out. Now the greatest possible integer value, if you draw it on the curve, then this will be like a step. That's why we call this as a step integral. This is 1, this is 2, this is 3, this is 4 and this is 5. Now here, whatever the value you consider in between, this will always lead to the greatest positive integer of 0. And whatever the value you consider in between 1 and 2, the greatest value is always plus 1. So this is plus 1. And from here 1 to 2, it is always plus 2. And here this is always plus 3. So this is always plus 4. So this is how the curve it will be. So that's why this is called as a step. So it's like a step. That's why step x. Got it? So now actually if you want to find out the integral of it, this value integral 0 to infinity step x into or step of t into e power minus t dt. So this value you can integral divide you can it. So 0 to 1, this is 0 into e power minus st dt plus 1 to 2, this value will be 1. So this is e power minus st into 1 into dt plus 2 to 3, this is e power minus st into 2 into dt plus integral 3 to 4, this will be e power minus s2 into 3 into dt plus dash 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 up to infinite. Got it? So this value, you can find out the integral for it. So this integral will be, first integral will be 0 plus second integral will be e power minus st by minus s. Upper limit will be 2 and lower limit will be 1 plus. So this integral will be e power minus st divided by minus s, and this is 2. The upper limit will be upper limit will be 3 and lower limit will be 2 plus 3 times of into, so this is e power minus st by minus s, and upper limit will be 4 and lower limit will be 3 plus dash 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 up to infinite. Now you will have to substitute the limits, and then this is minus, so 1 by minus s you can take it out, minus 1 by s if you take it out, this is upper limit will be e power minus 2s minus e power s minus s plus 2 times of, this is e power minus 3s minus e power minus 2s plus 3 times of e power minus 4s minus e power minus 3s plus dash 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 up to infinite. This is, if you take it out, e power minus 2s here and e power 2 times of e power minus 2s there. Here, if you take one more minus out, this is 1 by s times of e power minus s plus e power minus 2s plus e power minus 3s plus e power minus 4s plus dash 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 up to infinite. Right? So this term and this term, it will be cancelled out, and there will be only one e power minus 2s will be left over. That's what I kept it here. Now if you take from the second step, this is 3 times of e power minus 3s, this is 2 times of e power minus 3s. Now plus 2 and minus 3 is leads to minus 1. So that minus 1 I have taken it out. So this is 1 by s. Now this is a geometric progression. A geometric progression for an infinite sum, this is a by 1 minus r. So that is 1 by s is out, and then a is the first term e power minus s, and the common ratio is e power minus 2s by minus s is e power minus s. So 1 by 1 minus e power minus s. This is the Laplace transform of it. Clear? Any questions? Or not? So as a homework, you take it, find the Laplace transform of a periodic function of time of period t. Find the Laplace transform of a periodic function of period capital T. You take that as a homework. So this is about the basic introduction of Laplace transforms and finding out the Laplace transform of some of the basic functions. Now in tomorrow's class we are going to discuss what are some of the basic principles or the theorems that are involved in finding out the Laplace transform, which will make our work simpler for finding the Laplace transform. So after that we are going to discuss the inverse Laplace transforms. Clear? Any questions on this? Any questions on this? So this you take as the assignment. So that's all for today. Yeah, thank you.
Yeah, good night.